So on that note, obviously I'm here today to talk about the cryptocurrency Monero. It is a secure, private and untraceable currency, but I'm going to start off just by introducing myself. So my name is Justin Ehrenhofer. I'm a second-year university student at the University of Minnesota studying finance and management information systems. At Minnesota, I'm also the president of my school's cryptocurrency club there, and I'm currently on an exchange program at the Vienna University of Economics and Business, which makes it a lot easier for me to come to Poland and give some talks. So on Reddit, you might see my username as Samsung Galaxy Player. No, I'm not endorsed by Samsung or anything, but I just needed a Reddit username, and that was the tablet I was using at the time to use Reddit, so I was a little lazy, and that was the name I chose. So as far as my connection with Monero, I am not a developer and I'm not a core member of the Monero project. I'm just an avid enthusiast, and my role mainly has been documentation and recently giving talks like these, taking advantage of my time abroad in order to speak throughout different cities in Europe. So I obviously enjoy that because I really like talking about Monero. So one thing with Monero is that we really try and solve the idea of privacy for transactions. And most people will respond saying, well, I understand why maybe some drug dealers might want some privacy, but why should I care about privacy if I'm just buying groceries? And I completely get their point of view because they don't think they're doing anything that maybe they're worried about hiding from other people. But I want to introduce this idea of just a concept that is involved with money, and that's the idea of fungibility. It's a weird word, but all it means is that the value of one note is worth the same amount as another note of the same value. So 10 euros is worth the same as another 10 euro note, assuming they're both legally issued. And so most of you are probably used to this, where as you're using cash, it doesn't matter if you change a 20 euro note for two tens, but when you're able to look up the history of how the money was spent, some people might not accept certain coins based off how they were previously used. So you might have one Bitcoin in your balance, but maybe no exchange or no person will accept it. So theoretically, even though it has a value, no one accepts it, so it's truly worthless. And so this is obviously a property we want to protect with Monero. And I'm just going to walk you through an example about how you, as a user making normal transactions, can kind of get wrapped up in this problem. So again, let's assume that this is you, and let's say that you receive money for a book you sold from someone. You receive money in Bitcoin, and then you use this money to purchase a legal medical product that you need. And then let's say that you sell a concert ticket to someone. Again, you receive the Bitcoin, and then you pass it along to your best friend in the form of a gift. Now again, all these are completely legal. There's nothing wrong with any of these transactions. But when you're able to look up the history about who you're actually transacting with, things might start to look a little bit suspicious. So let's say that you sold a book to a known extremist, and then you had to buy your product from Hemorrhoid Cream Direct. So now everyone knows that you're getting money from an extremist and that you needed to purchase hemorrhoid cream, and this is recorded in the blockchain forever. And so obviously some people might not want that. Second, let's say that you receive money from a drug lord, and then you pass that drug money on to your best friend. And now maybe you or your friend are questioned by the police because this money was previously used for drugs, and they want to make sure that you aren't using it for that reason too. So you can see that even with a normal transaction where you're not doing anything wrong, it's important to have fungibility in the system, and Bitcoin just does not have the fungibility, and that's why Monero tries to provide it. So, how is Monero different? So across the whole scope of the transaction, it really protects privacy in these four distinct ways, and we're going to get in detail about how, in each of these four ways, how it really works. So first, the sender of the transaction is hidden with ring signatures. Beginning in January, the amount was also hidden in the transaction with ring confidential transactions, which was our take of confidential transactions for Bitcoin, but just adapted to work with ring signatures in Monero. Then we also hide the transaction broadcast for who's requesting the transaction on the network. We're still working on getting this finished for making it hidden, but to do that we're working on Kavri, which is an I2P router implementation. And then finally, we hide the receiver in the transaction with something called stealth addresses. So just jumping directly into the first one about ring signatures. So I want you to imagine the idea of the whole blockchain or as a ledger, as was discussed earlier, and you can really think about this as just a whole bowl of all the money that exists. So all the Monero that exists or all of the euros that exist. And each of these rectangles that are on the screen there just represents a certain amount. So you can think of that as your euro notes or coins. In this case, they're just denominations of Monero. And let's say that this highlighted red one is one that you have control over and it would show up in your wallet balance. It's as if you had, like a 10 euro note in your wallet. And so the whole point of how we hide the sender is we want it to make ambiguous which input is actually used in the transaction. So we don't know that this red one is the one that's actually being spent. So how do we do that? What we do is we look at the copy of the blockchain, and you can do this entirely offline. You don't need to be connected with to the network to sign this transaction. But what you can do is select other people's inputs that you do not control, and you don't need their permission to take them. To your intents and purposes, it's just some number that you can use. And the idea is that you hide which of these inputs is the one that's actually used in the transaction by hiding it among all of these. So all of them, whether they're highlighted blue or red, appear to be spent, but we know that only the red one is spent. So if you put that into the actual transaction, again, we start with yours as the input. Your wallet software will automatically select random other inputs from the blockchain. In this case, I chose 5 others. And then so that makes a ring size of 6. And the idea is that among these inputs, again, you don't know which one is actually being spent. We know it's red, but no one else that looks at the blockchain would know. Currently on the network, you need to have at least 3 inputs used in a transaction, so at least 2 others. If you don't use at least 2 others, the network will reject the transaction. So it needs to also use other people's inputs. Later in September, we plan to increase the number to at least 5, if not more. We're still having some discussions about that. Because obviously, if you choose more inputs that are used in the transaction, that means that instead of, in this case, there's a 1 in 6 chance that it comes from your red input. If you chose 10 others, then it would be a 1 in 11 chance, and that's obviously better. One question we constantly get is, if you get to borrow other people's money, what prevents you from actually spending other people's money? And that's where the special thing called the key image comes in. It's like a hash, so like a reference to the input you do have, except, and what you do is you include it in the transaction and you tell the rest of the nodes about it, and they just verify 2 things. One, that they haven't seen it before, so you're not trying to double spend the money. Or 2, that it's an actual reference to the input you do have, so you can't spend someone else's. So this is how transactions worked basically up until January. We used the entire inputs of both your inputs and also the inputs that you also selected. But in order to also hide the transaction amount, we decided instead of using the whole input, how about we just use a fraction of these inputs that only you know the fraction of. And that's where ring CT comes in. So you can see now in this case that right now we're using only about half of the input, but it will vary based on each transaction, and no one else actually knows how much is being used. To actually implement this, it's this fancy math just called a Pedersen commitment. I'm not going to get into the specifics of how the Pedersen commitments work, but the general idea is that just allows you to break up the input into pieces that only you would know. And then finally, you take your input, the other inputs, and use a fraction of them. You end up with a ring CT ring signature, which just signs the difference between these commitments, and then you end up with an unknown amount of XMR. And then as an output, I'm not going to talk about this, but you also broadcast the commitment public key, so other people, it basically proves that you have the right to use the fraction of the input without other people knowing how much of the fraction you're actually using. So that's the general idea about how ring signatures and ring CT works for an individual transaction. Now let's take a step back and see how it looks like on the whole blockchain. So on the left-hand side here, you can see all the inputs from before, and on the right-hand side, you can see some history I pulled up about when each of these inputs was used from a block explorer. So again, we have our input here, and I boxed the history in red just for our specific input for about a month of history. And the arrows refer to a time that this input was included on the blockchain somewhere. There are really three ways that this can happen. One, it's either new money, so it's a coin-based transaction, we're seeing it for the first time, and so then it's included in a block somewhere. Two, you have control of the input and you're spending it, and so therefore it needs to be included in the blockchain for it to be spent. Or three, someone else borrows your input that you control and spends it in their transaction. So since you have the ability for other people to borrow your inputs, you don't actually know how many times or when your input is actually spent. So with all these arrows, you don't know if it was spent none of these times or all of these times. There's no way for an outside observer to know. So that's pretty cool. In relation to Ring CT, it is currently an optional yet default feature. It will become mandatory in September, but we're seeing that we have near 100% use on the network already of this optional feature. So that's really cool that the network adopted it so quickly, because people noticed that they have such good privacy advantages for using Ring CT over an old legacy transaction that didn't support it. So many people understand why you want to obfuscate information on the blockchain, because everyone can audit it forever. Like I have a copy on my computer so I can look at everything. So people understand why you should hide that, but they often forget about how it actually gets there. And this is where we talk about how you broadcast the network to the rest of the peers. And so let's say that you are this green node and that you are the one who wants to request a transaction just to send money to someone. And in order to tell the rest of the network, you need to connect to the rest of the peers and tell them that I would like for this transaction to be included in the next block on the blockchain. And when you're doing this, some of the nodes that you push this request to might not be playing nice, and they're just logging the first IP address that they received this transaction request from. So you see in this case that you pushed out your transaction request from your home IP address to the node directly. And there's no way for you to know which of the nodes are logging. So you can't avoid ones that you know are bad because you don't know which ones are bad. And so in this case, the logging node gets your IP address and says, hey, this is the most likely origin of this transaction. Like, this is the most likely sender. They don't know any information about what input is the one that was actually used or who it's going to, or even how much is being spent. But they can come knock on your door and say, hey, we think you sent this transaction. Tell us the information that's hidden on the blockchain. We want to know about this information, what you know about it. So this is obviously not ideal because we want to have protections against this, especially in situations where it might be hostile for people using Monero. So in order to help alleviate this privacy issue, we're building up a Kavri router, which is an I2P router. Can I just see a show of hands how many people have heard of I2P before? Okay, none. How many people have heard of Tor before? Okay, so it's the majority. So I2P is a hidden service similar to Tor. It is much worse for accessing normal websites like Facebook and Google, but it is better for an inner peer-to-peer network. So you can think of how you relay Tor through relay nodes and such. With I2P, each participant in the network is also a node, so you kind of send network within the I2P network to other participants on the network. And so the whole idea is that we can hide the actual IP address so that instead of them getting your actual IP address, they just get a meaningless and not associated with you in any way I2P address. So you can't prevent the nodes from logging, but you can just give them useless information so that when they log it, they don't know anything about who's sending these transactions. We don't plan to send all block data through I2P. We will have the option in case the government says like you can't use Monero at all. You can just put it through I2P and people won't know you're actually using Monero. But for most people, we're just going to put this transaction request because that's the biggest privacy leak that we have. So now just moving on to the last component with stealth addresses. We start with your input as before with the ring signature. Either we have an unknown amount with a ring CT transaction, or we have a known amount if you're using an old non-ring CT transaction. And from these, instead of sending it to an address like you do with Bitcoin, you send it to a random hash that the private key of the recipient can still know is for them, but instead of the address being recorded as the receiver, it's just a hash that isn't actually has any correlation to an outside observer to the address you're sending it to. So you can see that here it's just like a list of numbers and letters that you're sending it to, and these will never appear ever again on the blockchain, so this is the only time it ever shows up. And you can't go from here to the address that you're sending it to, but you can go from the address, you can look up which outputs are actually yours. Another cool thing is that you don't know that these outputs are all even going to the same person. So in this case, the red ones are going to the receiver, but the blue ones are coming back to the sender. We often use this if you have a very large input. So let's say you have a 10 Monero input and you only want to send 2 to somebody. You can use the 10 and send 8 back to yourself as change. So that's how we break up these really large inputs. And then we have the commitment public key that's an output that I'm ignoring again. So just in summary, we have an ambiguous input that is actually the one used in the transaction, because in this case it's 1 of 6, and they all look identical, so you can't really eliminate one of these options. And then we have an unknown amount of each input that is used to cause an unknown amount that's actually sent in the transaction, and then finally it goes to an unknown set of addresses. You don't know what addresses they're going to. So that's pretty cool that across the whole blockchain, all the information that was discussed earlier about what's recorded, it's all obfuscated. One thing that we're really passionate about in the Monero community is that we think that all transactions need to be private by mandate. It can't be some optional feature that you allow some people to use. It needs to be something that everyone is using in order to be effective. And part of this just comes from our own history. So last year, around this time, you didn't need to send a transaction with any other inputs. You could just take your input and you would still have the stealth address system. But everyone would know what the origin of the money was, which specific input it was. And that wasn't good for 2 reasons. One, if you were sending the transaction, obviously that transaction itself is not private, and it's a big deal if you're doing that accidentally, because now it's recorded forever. Oops. Or 2, the strength of the Monero network is based off other people borrowing your inputs. If no one else in the network is borrowing others' inputs, it's less convincing to say, hey, I might not have spent this, maybe someone else did, if no one else is borrowing inputs. So that was obviously a big concern to us, and a year ago, only 1/3 of transactions actually use this privacy feature, which we think is essential, so we made it mandatory. So now all transactions have to. On the right-hand side, you can see a similar coin that explains that they have the most private transactions possible, but only the red proportion of the coins are actually held privately. The green ones are as transparent with Bitcoin transactions, and obviously if you're using this coin, most people that use it probably don't realize that their coins are just as transparent, and they think it's private when it's not, so that's a big issue. If you're using a service where only a certain percentage of the users actually use the privacy feature, your anonymity set isn't for how many users are totally using the coin, it's just for the users that are using this privacy feature, which is usually much less. In this case, it's only like 5%. So just moving on to a brief history of Monero real quick. So like Ethereum and pretty much every other coin besides Bitcoin, it was launched in 2014 by a person named Thankful for Today. He ended up being really hard to work with and tried implementing some really controversial changes. So a few weeks in, the Monero core team forked the project away from him because none of the community wanted to have the person who launched it continue to be the acting developer. And so since Monero is not based on Bitcoin, it is not a fork of Bitcoin, it's based off something called Crypto instead, they were handed this basically brand new code that they had to learn how to use. And while they're trying to figure out how it actually worked, a motivated attacker used an exploit in the Monero code by spamming a very large number of transactions to force a hard fork. So to our knowledge, nobody really lost funds because of this, but it really was a turning point in Monero's history because we realized that the security of the network can't just be something that's loosely talked about. It needs to be an integral focus of what the network is about. So not too much seems to have happened between September 2014 and April 2016, but during that time a lot of back-end work was happening. We switched to a completely different databasing system that was about twice as efficient. There are Monero Research Lab papers that discuss how we could improve the privacy and security of Monero, and really all those implementations finally came into fruition in April 2016 when, among a ton of other things, we made it so all transactions were private by mandate on the network. In December 2016, we finally released our first graphical user interface. Before then, we told all of prospective users that if you want to use Monero, you can use the command line, and it's great and lightweight, so you should. And no one liked that, I mean, including me. I did, but I didn't like it. So obviously the graphical user interface is a big step forward, and it really was our first step forward for making Monero easier to use for most people. And then finally in January, we enabled Ring CT on the network, which was the biggest privacy leak until that point. So if all transactions in the Monero network are private by mandate, how do you have any transparency or regulatory compliance, or if you needed to keep track of something, like how would you even do that? And Monero has a special thing called the view key. And I'm not really going to dive into the cryptography behind it, but it's just this transparent key that reveals either the incoming amounts for an entire wallet or address, or just the incoming information for one specific transaction. And then you can either post this on your website for the world to see, or you can just give it to one person. And remember, these people can see the incoming transactions for an address or just for one transaction. For auditors, you could give them your view key so that they can look over the accounts, make sure everything's in order. But since you're not giving them your private key, they can't actually spend your funds. So this way they can keep track of what's going on without actually being able to spend your funds, and we think that's very important. The most commonly explained use case for the view key is for a charity. So let's say they publish a Monero donation address, and they can publish their view key with that. That way everyone can verify how much money is coming in and compare that to their balance sheets to make sure there's no widespread corruption going on. And then finally, with parents, they can have some level of oversight over their children's accounts. So we can see that Monero still provides a case for if a transaction needs to be private, except it's not some feature that you can opt in to use privacy. Instead, you can opt in instead to have some levels of transparency. So it's like the opposite. So I want to also talk about some of Monero's limitations and how we want to approach those. So the biggest one I want you to remember is just that since Monero is not based off Bitcoin, any work that has been done for Bitcoin needs to be rebuilt from scratch to work with Monero. So this means that whereas it's easy for some exchanges to add forks of Bitcoin, like most other coins, it takes a lot more work to add support for Monero. So we don't have a reputable mobile wallet yet, and we don't have any hardware wallet that supports Monero. So those are obviously things that we wish we had support for, and we have people from both that work on both wallet software and on hardware wallet software that they would like to add Monero, but they're still in the process of trying to add it. So again, it takes a lot more work than a clone of Bitcoin. Now the biggest long-term problem that Monero has is that the transactions are very large. And that's just because in the blockchain, by obfuscating the sender and recipient, we have to include a bunch of other data to try and hide it. And so I'm just going to show you how much bigger the transactions are than a typical Bitcoin transaction. So a typical Bitcoin transaction is about 0.3 kilobytes. Before Ring CT, Monero was about 3 kilobytes, so it was already 10 times larger. And then once Ring CT was implemented, we jumped to about 12 to 13 kilobytes. So you can see we're 40 times larger than a normal Bitcoin transaction. And so this is where you hear people in Bitcoin, and right now they're having trouble scaling themselves. They tell us that there's no way you can scale, right? And so I want to address our approach to that problem, because obviously if we do meet or exceed Bitcoin's current use, this might become a long-term problem. In the short term though, we can see that at a blockchain size, an optimized size of 13 gigabytes, it's not an immediate short-term concern, but it's obviously something you want to look forward to mitigating the impact of. So really our approach to this is like 4 ways. So first, Ring CT is brand new. I don't know how we can optimize it, or else it could already be optimized, but I anticipate that as the developers make some tweaks with the software, that I estimate that the transaction sizes will be reduced by about 20%. Again, that's my guess. It could be 0%, it could be 80%, I don't really know, but I think a reasonable number is about 20%. Second is pruning. So pruning is where you discard unnecessary parts of the blockchain that you don't really need anymore. With Bitcoin, you know when each output was spent most recently, so you can just get rid of all the previous history of this output. However, with Monero, since you don't know when the money is actually spent, we still need to keep a copy of that forever. So we can't prune nearly as much information as Bitcoin, but we can still remove about half of the information on the blockchain, which is obviously getting us somewhere for a decent amount of, at least reasonable scalability. Another option that's still on the table is sharding. This is where you basically take the blockchain, you kind of treat it like a torrent, divide it into a bunch of different pieces, and put those pieces on different nodes across the network. And this is obviously would be helpful because then you can have smaller size requirements for each node, but we just want to make sure the network is decentralized enough that it would still, stay decentralized, and it would be harder to try and attack these nodes. Third is that in the worst case scenario and nothing changes, hard drives are still pretty cheap. We think that if we meet any large amount of transaction volume in use, that enough enthusiasts would either purchase a 1 terabyte hard drive or already have one lying around. And again, you can purchase a terabyte hard drive for $30 US. So in this case, that yes, it would kind of suck for VPS providers, but if you're running your node on a VPS, it doesn't really help the network be decentralized anyway. If Amazon is just running 500 nodes on the same, their same data center, it doesn't really add to the decentralization anyway. And then fourth is that we think that any real scaling for large use, like 10 transactions per second and larger, needs to be done off-chain anyway. And so think about if you're making like a low-risk transaction for maybe €5, and you're anticipating that someone's not going to try and outpace the entire Monero mining network to reverse your one small transaction. If you're pretty confident about this, you can still, if you're paranoid, use the blockchain, especially for larger amounts, why that would make sense. But if you aren't that paranoid about it, you could use the sidechain and have an instant confirmation. You can pay, you could obviously have much smaller transaction sizes and therefore pay much smaller fees. So it really is a benefit for everyone, and that's something we're really optimistic about. Technologies going forward like Lightning Network or sidechains like Mimblewimble. Okay, so what's our ongoing development? I mostly highlighted some of the more tangible items. We have 140 contributors in the past year, so I can't talk about everything everyone is doing, but these are some of the major items. So first, multi-sig. Right now, if you're using Monero to purchase something from a merchant, you need to give money to the merchant and hope they don't just keep your funds and actually send you what you bought. And obviously that's no good. So in order to help increase usability, we can incorporate multi-sig, which is currently being worked on. That way you can kind of throw an arbitrator in between so they can reverse the transaction if something goes pop. Second are sub-addresses and disposable addresses. So Monero is private on the blockchain, but if you publish your address in multiple different donate locations, like on your Facebook, your Ashley Madison website, and your Alphabay website, on your Alphabay account, for instance, and I don't know, then in that case, obviously you're creating an association between yourself and how you're using it. So in this case, you would kind of have like a master account, but you can create like sub-accounts that would still send money sent to those accounts would go to your master account, but it would break the link for your addresses appearing in multiple locations. Right now, you would have to use a different address if you tried to improve your OPSEC that way. Third, translations. The contributors worked really hard, and we had dozens that stepped up to try and improve the amount of translations we have. Concerned, it's all in English. So this is something that we obviously need to work on, and if you were interested in Monero, I encourage you to look into this because you can just contribute on GitHub pretty easily. And that would obviously increase accessibility for a lot of users. Fourth, dynamic fees and dynamic block size improvements. So Monero does not have a hard-coded block size limit. Instead, it's capped at a certain growth rate. And what we've seen as people adopted ring-CT faster than we thought is that the size of the blocks grew faster than we thought. And as a result, we currently have mempool backlogs. So I'll talk about why or what we're doing to solve that issue in the next slide, but just know that this is something that we obviously don't want on our network. Fifth, lightweight wallets. Our Monero core maintainer is working on a lightweight wallet for Monero. That way it's safer for you to use Monero without connecting to using a web wallet, or if you don't have a full node on your computer, but we still obviously want people to run full nodes. And then last, we recently funded someone to work on a website redesign, because ours isn't really terrible, but it's not the most intuitive, and this is a better way to present the information. Okay, so a hard fork schedule for Monero. So this year, we have 3 hard forks. One already happened, and one is happening tomorrow. So, on the one happening tomorrow, that brings the dynamic block and dynamic fee improvements so that we will hopefully no longer have these mempool backlogs anymore, and it will reduce the cost of sending transactions by just a little bit. In September, you can think of it as like our privacy update. In this update, we plan to have mandatory ring confidential transactions, so the handful of people that aren't using this feature will be forced to at this point. And then we'll also increase the minimum ring size to at least 5, although like I mentioned earlier, it might be as high as 10. The ones that are not in bold are kind of my assumptions for what will happen around the release time. It's not specifically tied to that release though. And those include fluffy blocks that just reduces the amount of redundant sync data that is sent between nodes. And then also wallet sync optimization, so that while you're still waiting for your full node on your computer to sync, you can still receive and send transactions, even though it's not fully synced yet. And you can also just use your computer more effectively to synchronize your wallet faster. Okay, so that's about all for my presentation. I hope I piqued your interest about Monero for the short time I was able to talk. Our website is getmonero.org. We have a very large Reddit community, and we have a very good technical Stack Exchange site if you're curious about more of the specifics about how Kavri or how ring-CT work in detail. That would be the resource to use. So I think we have a few minutes for questions, so if any of you have questions, I'd love to answer them. And if we want to move on with the next presentation, then I can answer some after the meeting too. So thank you, everybody. So does anyone have any questions then?
What's the market cap on the...
Currently? So it's currently about $300 million. Dollars. My brain thinks of dollars. Yes.
I have a question about different project, which is, I heard also about privacy, and probably you know about it more than I. Do you know what the PIVX is, and do you can tell anything good or bad about this project? How is better or worse than Monero?
Okay, yeah, so PIVX is, recently came like under a lot of additional focus. And it's literally a fork of Dash with a few changes. So if you're familiar with how the Dash private send feature works, it's the same for PIVX. And I actually have a diagram that in my longer presentation, so it's right here. This is kind of how they use their coin join implementation. So it wouldn't be Bitcoin, it would be whatever the PIVX currency is. But you would have 4 different users that take their coins, their PIVX coins. They would send it to a master node. This master node would mix up whose is whose, and each person would end up with a fraction. And so we really, in my opinion, there are 3 issues with this. So first, the only people that use this feature, because it costs extra money to use and it's not mandatory or default feature, are people that have tainted coins. So if you have a bunch of people that are just mixing drug money together, I mean, it doesn't really improve your privacy if you're just mixing with other people's drug money. Second is that you have to trust that this masternode deletes the logs, but they might not. They can keep the history of where the money goes. And so what they do to try and mitigate this is that they tell you can send it through multiple masternodes, so you can send it through like 8 or 9 masternodes. And their idea is if one of them deletes the history, then you should be good. And the problem with this is, I mean, it still is a systematic risk, it's just kind of mitigated. And if you have the same people running a large number of these nodes, it starts to increase it like an even larger risk. And then finally, just like from a practicality standpoint, depending on how much you're sending, it could take a very long time. Because if you're this participant, you need to wait for 3 other people to volunteer to also participate in this. And if you're one of only 2 people that want to use this feature, you're going to be waiting forever. So it won't actually mix until other people come in. So if you're mixing like 1,000 dash, it could take a month for you to go through 8 different masternodes. And obviously that varies based on how many people are using it. They have been saying, at least in the Dash community, that as use of Dash increases, this will no longer be an issue. But currently, it takes like 3 weeks, and the use has increased significantly over last year. So I'm not confident that even if a lot of people were using it, it would be like an efficient way. Right? Like with a Monero transaction, you could say, I want 100 other inputs used, and it would sign in like half a second. So as far as practicality, I think that would be a reason to use at least Monero's privacy, because you wouldn't have to wait forever to send a transaction, right? Okay, so did I answer that like pretty thoroughly then?
Yeah.
Okay. Any other questions about other, since we're on the topic of other coins, anyone have any questions about other coins or anything else?
What if we talk about other coins? What do you know about Viacoin?
Okay, so
Maybe we.
I don't know for sure. So if my memory if my memory recalls me correctly, that I think, wait, Viacoin or Vertcoin?
Via.
Okay, then I don't know.
VIA.
It's so small.
I don't know that.
It's a small market cap.
I think, it seems like you know, is Vertcoin, I think that is a fork of, from CryptoNode, right? I know I've never heard of Viacoin before. But for Vertcoin,
So-
okay. Yeah, sorry, I don't know about that one. I'll have to look at it into it. Okay, maybe just one more question then, I can turn it over for Steve. Okay, well then feel free to ask me anything after the presentation, but thank you so much again.